Hello again and welcome to the third part of my series about getting started with 12-volt Lego trains. If you haven't watched the first and second parts of my series, I highly recommend that you watch those first because they contain useful information regarding entering the 12-volt world. The first part details the different core components of a simple 12-volt layout plus a section about voltage converters for users outside of Europe, and the second part overviews the 9 12-volt train sets in addition to some advice on your first round of purchases. This part will be about how to set up your 12-volt train once you receive it. Assuming you have all the core parts I went over in the first part of this video, those being a train, at least a circle of track, the transformer, and if you're outside of Europe, a voltage converter, the first thing to do is set up a loop of track. I went over the parts for assembling the track in the second part of the series, so now I'll show you how to assemble the track. Overall, it's pretty simple, but make sure to follow what I'm doing. First, you need to take a sleeper plate, and then attach the outer plastic rails, one on either side, to it. They just snap into place, like that. If you're assembling a curve, make sure to have the longer rail on the outside of the curve because, again, the length of the outside rail needs to be longer than the inside curve. You put another sleeper plate in the middle, and then you can put another one on the ends and then repeat the process as necessary until you have as much track as you need. The instruction booklets recommend assembling an entire loop of 4.5 volt track before you insert the 12 volt metal rails, and the 12 volt rails are they're connected before they're pushed down onto the sleepers, and then make sure to push them down firmly. So a completed quarter or 4.5 volt track is going to look like this, and then once the metal rails are installed, it'll look like this. And then you'll need to attach the wire which connects to the transformer. That's pretty easy. If you're using the separate wire part, it'll need to be installed like this. You can see there's one plug in each of the cable connection holes. This can only be done with the rail with the cable connection holes. You can't do it on a rail that does not have cable connection holes. And then the wire just runs under the track, and you can see this part goes all the way to the other end, which is connected to the transformer. You can also use a special curved rail segment that has a wire that's already integrated into it. And you can see the block on the bottom. That also is an interference-free rail. And then this plug is connected to the track, and that just plugs right into the transformer. Once you have a loop of track set up, the next thing to do is connect all the wires. So the first thing you'll need to do is plug the track into the transformer. If you're using a separate wire part, you'll need to plug one plug into each side of the variable output on the transformer. If you're using the track with the integrated wire like I am, that is already sized so that it'll just slot in, and then you'll have to connect the transformer to either a voltage converter or directly into the wall. Here I have it plugged into the voltage converter. The voltage converter is plugged into a power strip, and then you have to turn that on. Now you're ready to put the train on the track. The final step is to put your train on the track and run it. Make sure the speed throttle is on neutral, otherwise the motor will start turning as soon as you put it on the track. I'm using the 7745 for this video. When you're putting the train on the track, make sure to align the wheels correctly, because if there's a contact that is not touching the metal rail or is touching both of the metal rails, the train won't run. In fact, it will short circuit if the contact is touching both of the rails. I'm just connecting the wire here because the 7745, as you may know, has a light in the last car of the train, which needs to be powered by a light, but the only point of connection to the track is in the motor. So you have a wire that goes through the entire train, and then hopefully you set up everything properly, so if you turn the speed throttle, the train will run. I like to set it up so that the train moves forward when the dial is turned clockwise and backwards when the dial is turned counterclockwise. If it goes the other way, you can very simply flip the wire that connects to the transformer, since that will reverse the polarity. So here, if I'm turning the dial clockwise, the train moves forward, but with this wire, if I take it out, flip it around, plug it back in. It'll go the opposite way when it's turned counterclockwise. If the train does not run when you turn the speed throttle, first check to make sure all the connections are secure. The transformer should be plugged all the way into the wall outlet or an active voltage converter, and the track should be plugged into the variable output. If it runs but stutters, you may need to clean the metal rails or motor contacts. If you start up your train with the transformer and it's running like this, and it's stopping once in a while, you'll need to clean the rails and the contacts of the motor. This happens often with my trains if I leave the rails out for a while, because dust collects and the connection between the rails and contacts is poor. I'll make a video on how to do this soon. If you're sure the rails and contacts are clean and everything is plugged in correctly, you may have a more serious problem such as a broken transformer or motor. You can troubleshoot this by using a multimeter to determine if power is coming from the transformer and then testing different points along the circuit to see where the power is failing. If you get all the way to the motor and power is still active, you probably have a broken motor. Hopefully this doesn't happen, but these are old electric parts. Even the youngest 12-volt motors are about 30 years old, and motors made in 1980 are over 40 years old. If you run into problems, feel free to comment down below what the problem is, and I'll answer to the best of my ability. I've never had a motor that straight up wouldn't turn when voltage was applied. I have had experiences with broken motors though, and usually you'll hear a buzzing noise when it's trying to turn. There are several things that could be wrong with the motor: a bent axle, a broken piece of plastic, worn carbon brushings, no lubricant, or other problems. If you're sure the motor or transformer is broken, contact the seller you bought from to see if you can reach a solution. Again, hopefully you don't come across these problems, but it's always a possibility. Hopefully this video has helped you get your 12-volt train running, or at least given you some knowledge about 12-volt trains. The next part of the series will be detailing the different supplemental sets and which to purchase after you have your first 12-volt train set. If you enjoyed this video, make sure to subscribe. I'll see you in my next video.